Hello, this is the second homework of the probability, and here's the first video response. Okay, we're given a function which is multiplied by capital A, and we need to find out for which values of A the function will be a probability distribution function. Okay, from the equation we can see that without the A part, the other part is clearly okay. From our copy I can see that the other part is non-negative, non-decreasing, and it will approach 1. So if we keep the value of A equal to 1, then our condition is fulfilled. Now since we have taken A as 1, now by graphing the plot we will find out f of x. From our equation we can see that the exponential part is multiplied by a step function. So the step function starts from x is equal to a, and on that point we put the value of x is equal to a, and we get the value of that point 1 minus e to the power minus b into a. So from that point the exponential curve goes up and converges to 1 at infinity. So now in order to find the density function small f of x, we need to differentiate the distribution function. By applying the formula d dx of u v dx is equal to u d dx v plus v d dx u, we finally find out the equation for the probability density function. The density function has an exponential part and an impulse. So now we add them up in a graph to draw the PDF, and this is the shape of the graph with one impulse at x is equal to a, and the value of the impulse is 1 minus e to the power minus b into a, and then there is a slope connecting with that impulse, and it has a shape of b times e to the power minus bx. Now we have the second math. In order to find probability of x2 is equal to 1, we need to find out both the probabilities of probability of x2 is equal to 1 when probability of x1 was 0, and also probability of x2 is equal to 1 when probability of x1 was 1. Sorry, it will be probability of x2 given x2 is equal to 1 given x1 is equal to 1 times probability of x1 is equal to 1, and we have to add that with probability of x2 is equal to 1 given x1 is equal to 0 into probability of x1 is equal to 0. So we get that probability of x2 is equal to 1 is now 0.64. For the next part, probability of x3 is equal to 1, we need to find out two things. The first thing, we have already found out the probability of x2 is equal to 1 is equal to 0.64. We also need to find out probability of x2 is equal to 0, that probability. So now here we are finding out probability of x2 is equal to 0, and using the same formula from the previous part we find out that it is 0.36. And now the interesting part, probability of x3 is equal to 1 is equal to probability of x3 is equal to 1 given x2 was 0 times probability of x2 is equal to 0 plus probability of x3 is equal to 1 given x2 is equal to 1 multiplied by probability of x2 is equal to 1. So in this way we find out probability of x3 is equal to 1 is equal to 0.592. Now for the last part, we need to find out the probability when x1 is equal to 0 given that x3 was 1. So here we can see that using the formula of conditional probability we use the Bayes formula to divide the things, and now we find out for probability x3 is equal to 1 given x1 is equal to 0. So we have two conditions from x1 is equal to 0. There are two ways to come up to x3 is equal to 1, and we have summed up those two probabilities to find a result of 0.035 at the end.